So let us continue with the 13th problem, children. A boy of height 1.5 meters with his eye level at 1.4 meters stand before a plane mirror of length 0.75 meters. So let us try to picturize this. So what is given? A mirror was given. The height of the mirror, a plane mirror of length 0.75 meters is given. Length of the mirror is given to be 0.75 meters. Fixed on the wall. The height of the lower edge of the mirror above the floor is. So let us first of all also imagine that this might be the floor, ground, and from this the height itself was given as something like 0.8 meters. The height of the ground, the height of the mirror from ground is 0.8 meters and the length of the mirror was given as 0.75 meters. Now, a boy of height 1.5 meters with his eye level at 1.4 meters standing before the plane mirror. So, let us also consider a boy who is of length 1.5 meter. The total length of the boy, the height of the boy himself was given as 1.5 meters and some the eye is somewhere around yes, 1.4 meter. So, the total height of the boy is given as 1.5 meter and his eye is at a height of 1.4 meter. So, that means out of total 1.5 meters, the eye length itself was given as 1.4 meters. So, the remaining length would be 0.1 meter. So, I hope it is clear. 1.4 plus 0.1 is totally equals to 1.5 is the height of that total boy. So, these are the given data. So, what is given? Once again, let us look into that. A boy of height 1.5 meter with his eye level at, this is his eye level. Okay, 1.4 meters stands before a plane mirror of length 0.75 meter fixed onto the wall. The height of the lower edge of the mirror above the floor is given as 0.8 meters. Then, you are asked to consider which option is true. The boy will see his full image, can't see his hair, boy can't see his feet and the boy can see neither his hair nor his feet. For this, what we do is, let us try to check it out. Okay, so here it is 0.1 meters and here if you consider this from here to here, this particular length, if you consider, this is only just a separation I am giving you, children. If the total length happens to be 1.4 and this only this portion will be 0.8. If this is from here to here it is 0.8, here to here it is 0.1 and the remaining would be. So, 1.4, the total from here to here is 1.4 and here to here it is 0.8. So, 1.4 minus 0.8 must be equals to 0.6. So from here to here, this total length is 0.6. From very clear that this length is 0.1 meters, this length is 0.6 meters, and out of the remaining 0.8 meters, if you consider properly, then I would also like to consider one more 0.1. Suppose if a ray of light from the eye to the bottom edge of a mirror. This is 0.6. Again, if you go with somewhere around 0.6, then this is the reflected ray. That means he can see the path portion of the body from the bottom of the mirror only until here, because the light ray reflected from his body falls on this mirror, which is again reflected back onto the retina of his eye so that he can look into his picture. But here if you observe, only out of this 0.8 part we have until here, this is 0.6 means the same value here also 0.6. Now out of 1.5, this value is 0.1, here it is 0.6, 0.6 and the remaining would be 0.13. So that is 1.5 minus 0.13 will be something regarding 0.2. Let us check out the question once again, children. Boy of height 1.5 meters. So from here to here I have given you the complete height of the boy. So from here to here, let us check whether it is 1.5 or not. From bottom to the visible body 0.2 meters. Again from the visible body to some bottom of the mirror, here it is 0.6, up to eye, it is bottom of the mirror up to his eye 0.6 and the remaining head will be 0.1. Okay, this is 0.1 plus 0.6, it is 0.7, 0.7 plus 0.6 it is 1.3 and 1.3 plus 0.2 it is 1.5. Hence, it is valid. Now, if you went with this, go with this mirror length, it is 0.75. The bottom layer of the mirror is at a height of 0.8 from ground. So, all the details are clear. So, now let us check it out whether the boy will see his full image or not. Is it possible for the boy to see his full image? Well, in order to, here, of course, the total length from here to here is 0.6 plus 0.1, that is 0.7, whereas the mirror height is 0.75. So, very clearly, this 0.7 from here to here, it is only 0.7, but from the mirror height here is 0.75. So, very clearly, the height of the mirror is greater when compared to this portion of his body. So, whatever the light rays that are incident on the mirror can be visible. That means he can see the complete picture of his head. So, bottom, no issues. The boy can see even his hair. This is the hair of the body. He can see the hair. So, this statement must be false. This statement must be false because it is visible. The height of the mirror is larger when compared to the height of the hair. So, very clearly he is able to watch his hair. It is visible. So, the boy can't see his hair. No, it's a wrong statement. The boy can see his hair because it lies between the size of the mirror. The boy can't see his feet. Let us check with the third option. First option I will discuss later. Moving to the third option, this is the complete structure of the body. So, the bottom point of the mirror can only, up to this height of the body only it is visible. If you go beyond this, this portion of the body is not reflected inside the mirror. So, this portion of the body is not visible. He can't able to see his foot. Maybe this is the foot. So, the boy can't see his feet. Yes, it is true because this portion of the body is missing. So, option 3 is true. The boy can see neither his hair nor his feet. No, he can't see his feet, but it is very clear that he is able to look into his hair. So, this is also a wrong statement. He can see the hair. Of course, he can't see the feet. So, is it now moving to the first one? The boy will see his full image? No, a portion of the body is missing. So, he can't able to see the full image. Even this statement is false. So, which one is the correct option, children? The boy can able to see his hair, but he can't able to see his feet. That means he can't able to see his complete picture. Okay, some portion of it is missing. Hence, the correct option is option number 3. The boy can't see his full image, that is his feet. That's it. Okay. So, while moving to the next question, 14th one, to get the full length image of an observer of 176 centimeters. What is the height of the observer given? 176 centimeters tall. The minimum height of the required mirror is. So, in the concept we have discussed that the minimum height of the mirror to have a complete picture of the body must be half of the length of the given object. So, if the height of the person or object is h, means the height of the mirror must be at least a minimum of h by 2. So, given that the observer, so here the value is given as, the complete height is given as 176 centimeters. So, what is the height of the mirror? So, this is the height of the observer's height. Height of observer is given as 176 centimeters. So, no doubt the height of the mirror must be equals to half of the height of the mirror, that is equals to 176 upon 2. This must be equals to 88 centimeters, and hence the correct option is option 2, that is 88 centimeters. So, let us move to the next question, that is 15th question. Identical twins stand at equal distances on opposite sides of an opaque wall. So, what is given here? An opaque wall is being given. Some wall is there. Okay. Okay. So, and this wall is an opaque wall. What is the minimum size of a window which must be cut inside the wall? So, given that inside the wall, they have to cut a small window. Some window has to be cut. What is the minimum size of the window which must be cut into the wall so that they can obtain a full view of each other? So, who are there here? In both the direction, you have two identical twins are there. So, they want to look into each other. In order to look into each other to get the full image of the complete person, it's as like to a mirror image. Okay, same size, same height and everything. So, and here the window acts as if a mirror. So, the height of the window must be, means generally if it happens to be a mirror, the height of the mirror must be half of the height of the person. As it is window, the height of the window must be half of the height of the person, the twins. Clear? So, where is the correct answer? Half of the size of the twins. So, first option must be true. Half of the size of the twins. Okay. So, well, moving to the next question, that is 16th one. A man stands in a room with his eyes at the center of the room. So, where is the presence of the man? The man is standing inside a room and he is located at the center of the given room. The height of the ceiling is h. So, let us picturize this. So, a person is there. This is the room. Given that at the center of the room, this person is standing. Okay. Well, so man stands in a room with his eyes at the center of the room. So just concentrate on his eyes, where he is looking into. The height of the ceiling is h. Okay. The height of the ceiling, this total height, it was given as height. This is the ceiling. From bottom, it is height is h. The length of the shortest plane mirror fixed on the wall in front of the man. So he is looking here. So when he is looking into here, a mirror is being kept. A mirror is being kept. The length of the shortest plane mirror fixed on the wall in front of the man, so that the man can see the full image of the wall behind him. So no doubt, so he has to look. So whatever the distance from here to here, some x means the same will be from here to here. Okay. So for this wall, he has to look the image inside the wall. This means this will be whatever the distance between the man and the wall, again will be the same over the other side. Okay. So this is x, the mirror will be formed somewhere at x inside the mirror. This means x means here also x only. So no doubt, what must be the height of the mirror? It should be equal to the half of the height of the wall, because he has to look into not his height, he has to look into the height of this object. Object here is your wall. To have a complete picture of the wall here, to get it, what is the minimum height of the mirror? It should be something like of the same height reflected here also reflected in this direction. The upper layer reaches the upper part of the mirror, reflected back into his eyes. Bottom layer, after striking the mirror at the bottom point, again reflected. These rays appear as if they are coming from somewhere here. They are produced, they look as if they are coming out somewhere here, as if the light is coming like this. So what is the minimum height of the mirror? To get the complete height of the wall behind him, it should be equal to the half of the height of the wall. So what is the correct option? Answer must be h by 2. So that means, so this portion must be equals to this portion. Same case. Yes. Well, moving to the next question, paragraph questions. The phenomenon of left appearing right and right appearing left on reflection in a plane mirror is called as lateral inversion. So we are familiar with this. So right to left and left to right, this appearance itself, the name was given as lateral inversion. Based on that, question number 17, which of the following capital English letters does not show lateral inversion? For this, let us take a mirror and let us plot, write the letters here N, O, P and Q, and now you need to identify which does not indicate lateral inversion. N, after looking into the mirror, it appears as if it was written something like this. Lateral inversion. Same size. Yes. This N, whenever seen inside the mirror, this looks after lateral inversion will give this type of shape. O, as it is, same. P, left to right and right to left, and Q, something like this. Okay. So here N is varied because this slanting line is from top left to right side and here it is from right to left. O, as it is, no difference in O is been observed. P, this curved portion is observed towards right and here the curved portion is observed towards left. Q, this letter, this line is curved line is observed in this direction whereas the other line is observed. So here N, some difference is observed, P, some difference is observed, Q is also some difference is observed. That means some lateral inversion is being observed. Whereas for O, it lies as it is. So no difference in the O is being observed. So which of the following capital English letter does not show any lateral inversion? The answer must be O. Well, moving to the next question, that is 18th one. Which of the following capital English letter shows lateral inversion? The similar to the previous question. So again, let us consider the mirror in front of which these letters are being plotted. The letters are as shown. What are they? W, X, Y is written straight line here. So observe this, Y is a straight line. And last one is Z. Now let us also capture the mirror images of this. Yes. The mirror image of W will be something like this. X, Y and Z. Yes. So which of the following letters shows lateral inversion? W shows a lateral inversion. X also shows W, it lies as if the same thing. X also no difference is observed. Y also no difference is observed. But Z, some difference is observed because for Z, light appears as left and left appears as right. But for all other letters, they appear as if they are written. So W, X and Y does not show any lateral inversion, whereas Z shows the lateral inversion. Difference is being observed. Hence, the correct option is option number 4, that is Z. It shows lateral inversion. So now moving to the next question, 19th one. Which of the following capital English letters shows lateral inversion? Again the same one. Letters are something like this. Letter N, letter P and letter Q, which we have already discussed in your previous examples. Only 3 letters were given, children. One is N, the other is P and the other is Q. Only 3 letters. So let us check. N, after reflection, is observed something like this. P, after reflection, Q, after reflection. Yes. So for N also, left appears to right and right appears to left. For P also, left appears right and right appears left. For Q also, lateral inversion is being observed. So for all the 3 letters, we observe lateral inversion. Hence the correct option must be all the above. Okay. So 4th option is